This presentation looks to use the sine rule, and by the end of it you should be able to make calculations involving non-right angle triangles using this sine rule. First step is labeling the right angle triangle, or the non-right angle triangle, sorry. So really you can label it however you want. It's just a case of notation. So capital letters are representing angles, and opposite the capital letter, so opposite this angle of C, is a length C, which is in lowercase. So B and B, A and A. So capital, angle, lowercase, length. So the sine rule. The first, well, these are both sine rules, just written in different ways. The first one I would use if I was trying to find a length, and the second one if I was trying to find an angle. You only use two portions. It's written as all three, but you don't need the third calculation. You just need your appropriate two. So if you've got angle B and angle C, you don't need to use A for this, for instance. So just use the two that you need. And the appropriate one you need if you're finding a length or finding an angle. So when to use it? The sine rule is only used if you have two sides and angle opposite one of the given sides. So you kind of need to pair together an angle and a length, and then if you've got another side length somewhere. Or conversely, if you've got two angles and one side. So two angles and then one side which pairs with one of the other angles. Note, if you've got two angles, you can always find that third angle. So there's always a way to manipulate your triangle to find that third, just using that property that all angles will have to add to 180 in a triangle. So steps: sketch and label a diagram. As per normal, your first step is to sketch it. Once you've sketched it, identify what you want to find and what information you've already been given. So does this meet a sine rule situation? And if it does, then you can look to substitute all the information into one of those formulas. Make your calculations using the calculator, correct to whatever accuracy the question's asking for. So for this example, find C in the triangle shown, correct to one decimal place. Now, note the pairs of items. So I've got a pair here, which is C and C, 50 degrees, and we're trying to find a length C. And I've got a length B with an angle B, which I don't know, but I can always calculate an angle B. So angle B is 180 minus 100 minus 50. So all three angles in the triangle add to 180. So to find the third one, I do 180 minus 150 to give myself 30 degrees. So angle B is 30 degrees. In this scenario, I'm looking to find a length. I'm after the length of C. So if I'm after a length, then the format of my sine equation, or my sine formula that I'm using, is where my lengths are on the top of the fractions. You can use the other one, it's just more steps. This is, I suppose, an easier formula to use. Substitute in the values that we know. So we know that angle C is 50 degrees, we know that B is 8, and angle B is 30. Multiply both sides by sine 50. And then this is what we'd put into our calculators. So check to make sure you're in degrees. I am. So I'm going to do sine 50 times 8 divided by sine 30. I want that as a decimal. So 12.26, round it 12.3. Now, the sine rule, depending on the information you're given, may actually give you two different triangles. So this is a case where, or what we call ambiguous. This is the ambiguous case of the sine rule. So in this particular case, the information we're given is an angle, 40 degrees, a side length C of 9 centimeters, and then a length A of 6 centimeters. I kind of want you to imagine that this length of A the red line here, and the blue line here, are sort of a line that can swing backwards and forwards, and that at this point, C dashed and at C is where I hit the horizontal with respect to A. So it could be this line here, and then swing and be this line here, all right? Now those two triangles, blue and red, both represent triangles that are possible with the given information. If this is the case, we can still do our calculations using the sine rule. We just need to be aware of it. Now, our ways to check, to see if we can be aware of it, or to see if it is an ambiguous case, is 3 steps. So first one is, do you have a side-side angle case? So side, side, angle. The important thing is that this angle is not between the two sides. Okay, so it's side, side, angle. In this case, yes. Next question is the side length next to the angle bigger than the side length opposite? So side length next to the angle, C, is that bigger than the side length opposite? 9 is bigger than 6, so this is yes again. So the side length next to the angle always has to be bigger than the side length opposite for this to be an ambiguous case. The third thing to check is whether or not the side opposite, 6, is bigger than the side next times sine of the angle. So C times sine 40, is that bigger or smaller than 6? If 6 is bigger, so this is smaller, then again, we've got yes. Now, if we answered yes to all 3 questions, then your case is ambiguous. So I've gone yes, yes, yes. It is a case of side-side angle. My C is bigger than my A. My C times sine 40 is smaller than A. This is ambiguous. So these 3 questions allow you to check for an ambiguous case. If it is ambiguous, then you just do your calculations like normal. So do your first calculation, find that missing angle of C like normal, and then you can calculate the missing angle for the second triangle by going 180 minus that first triangle angle. And then can continue the calculations like it's 2 separate triangles, 2 separate calculations. Now, that sounds really confusing, but when you actually go through and do it, it's not too bad. So, for instance here, I've got an angle A, I've got a length A, I've got a length C, and I want an angle C. So I'm going to go sine C divided by C equals sine A divided by A, and then substitute in the values that I know. So this currently is like normal. This is what I've been doing previously. Okay, so substituting, rearranging, and then doing the inverse here. And once I've done this, I put this into my calculator. Sine inverse of 9 times sine 40 divided by 6. And I get out this result of 74.6185. Now, that is my value of C. That is this one in here. So that's my acute angle that's in here, 74.619 degrees. And I want to know also what is C dashed. So give the scenario in the diagram, calculate the 2 possible values for the angle C, correct to 2 decimal places. So I've done one value. I do need to do the other one. So I'm going to do my calculation. It is 180 minus C, where C is 7.62. Doing the calculation in my calculator. Note, I haven't used my rounded value, I've used the full value. And I'm going to get out 105.38. Now, what you should notice is that these two added together is 180 degrees, which means that this angle plus this angle is 180 degrees. And it looks like it. These are direct reflections of each other, these 2 angles in here, and then that's your I suppose, your outside angle. So there's that relationship, which allows you to calculate the information needed for your new C value. They're both degrees, and they're both my answer, so I'm going to red box both. Okay, last example, where this is a case of Leo wants to tie a rope from a tree at a point A to a tree at point B on the other side of a river. He needs to know the length of the rope required. So I'm going to draw the scenario. So the scenario here is two sides of a river where I've got A and I've got B. We're told that when he stands at A, he saw the tree at B at an angle of 50 degrees with the riverbank. So that's my 50. And then after walking 200 meters east to another point, C, the tree was seen at an angle of 30 degrees with the bank. So putting in that 30 degrees, and this is the scenario that I'm looking at. In order to do any calculations for this, and note that what I am trying to calculate is the length between A and B, I am going to have to know that internal angle. So sine rule requires the internal angle, which means that if I've got 180 degrees as a straight line and 50 degrees on the other side, then this angle could be written as 180 minus 50 or 130 degrees. Just using the property that a triangle adds to 180, we can say that the last angle in this triangle is 20 degrees. What this basically means is that I can use my pairs. So I'm going to pair 30 degrees in X, and I'm going to pair 20 degrees in 200. So I'm going to use C's and B's for my calculation. So C divided by sine C is equal to B divided by sine B. Substitute in the values that I know. So I know 30 degrees, I know 200, and I know 20 degrees. Rearrange my equation, and then this is what I'm going to put into my calculator. So 200 times sine 30 divided by sine 20. I want a decimal answer correct to two decimal places, so 292.38. And if you look back into the question, 200 meters, so our answer is in meters, so meters.